Welcome back to Summarize Science. Today, we're looking at how AI is being trained to become an incredibly sharp-eyed assistant in the operating room. Surgical video segmentation, which means precisely identifying and tracking instruments and tissues, is vital for computer-assisted surgery. Models like Segment Anything 2 or SAM2 are amazing at tracking objects in everyday videos, like a cat running across a yard. But as you can see in these diagrams, surgical videos are a completely different challenge. They can last for hours, not seconds, and feature unique obstacles like poor lighting, reflections, smoke, and constant camera movement. This creates a huge domain gap that trips up standard AI models. Furthermore, existing surgical datasets were often limited, making it hard to train a truly robust and general-purpose system. To solve this, the researchers first built SSV, the largest and most comprehensive surgical video dataset of its kind. It pulls data from 17 different sources, covering 8 types of procedures, creating a massive and diverse training ground for their new AI. On top of this new dataset, they developed SAM2S, a specialized version of SAM2 designed specifically for the operating room. SAM2S has 3 key upgrades that make it so powerful. First is DiveMem, which stands for diverse memory. Think of it as giving the AI a much better long-term memory, allowing it to remember an instrument even if it disappears from view for a long time and then comes back. Second is temporal semantic learning, or TSL. This helps the AI understand the difference between specific tools, like scissors and graspers, based on their meaning, which prevents it from getting confused by visually similar objects. And third is ambiguity-resilient learning, or ARL. This clever technique helps the model learn from data that might have slight inconsistencies, like when different hospitals label the boundaries of tissues a little differently. So, how well does it work? The results are impressive. As shown in this table, the new SAM2S model on the bottom row significantly outperforms both the original SAM2 and other advanced versions. These images show the difference in a real scenario. While other models lose track or make mistakes, SAM2S maintains a consistent and accurate lock on the target throughout the clip. So, let's recap the important points. The researchers created the largest ever surgical video dataset for this type of task, and then they built SAM2S, an AI with a better memory, a deeper understanding of surgical tools, and the ability to handle messy, real-world data. What does this mean for the future? This foundational model could pave the way for smarter surgical assistants that provide real-time guidance, enhance surgeon precision, and even help automate parts of complex procedures. It could also be an incredible tool for training the next generation of surgeons by analyzing their techniques. It's a huge step forward in making computer-assisted surgery safer and more effective for everyone. That's all for this episode of Summarize Science. See you next time.